Hi, Eleven. So here we've got a question on a velocity time graph. So let's take a look. It says a car starts a journey. Figure 6 shows the graph of the car's movements. Show that the distance travelled when the car is moving at a constant speed is greater than the distance travelled when the car is slowing down. Okay, so here where it says show, it just wants us to calculate to prove that point. And we are calculating the distance travelled. And we need to find out when it's moving at a constant speed and also when it's slowing down. So let's take a look at the graph and then pull out the information that we need. So this is a velocity time graph. So first thing you need to do if you get a graph on in your GCSE paper, you need to take a look at the axes, figure out what type of graph you've got, because distance time graphs, velocity time graphs, they can look very similar and we don't really get mixed up. So velocity. Velocity means speed in a given direction. And just while we're talking about velocity, we might also drop in that it is a vector quantity, which means it has magnitude, so a size of something, and direction. Okay, so there are two key bits about velocity. Now let's go through the sections of the graph. Here, you can see the velocity is at 0, and then it increases to 16. So this is showing an increase in velocity, otherwise known as acceleration. So the velocity's gone from 0, then it's gone to 16, and it's taken 15 seconds to do that. Here, the velocity is at 16, and then you can see it stayed at 16 from 15 seconds to 30 seconds. So that bit there is known as a constant velocity. It's not changing speed at that point, it's just stayed at 16 meters per second. This bit here, we've got a curve. So this is acceleration. However, it's different to the acceleration we just talked about here. So here, at this point, this is known as constant or uniform acceleration. Whereas here, it isn't constant because it's curved. So it's not uniform, it's not the same thing repeatedly. It's not constant, it's a curve. So it's acceleration. But we won't worry too much about that at the minute because the question isn't really about that part. Here, you can see the velocity is at 30. You can see it's between 28 and 32. It's halfway, so that makes 30. So at 30, it drops down to 0. So that would be known as either a negative acceleration or a deceleration. Okay, so the constant speed, we've just labelled it a constant velocity. In this situation, it doesn't matter that we've used different terms there. And then the slowing down, we've yet labelled as deceleration. So if I were you doing this question in the exam, what I would do is I would split the graph into parts with my ruler. So I'm going to split the graph and I'm going to show that this bit here, I know that that bit is where it's at a constant speed or a constant velocity. So this section. Here, at this part, I'll just change the colour. And be careful because it's not dead on 40, it's just 1 over. At this part, this is when it's slowing down. So what I need to do now is work out the distance travelled here and the distance travelled here. So in order to work out the distance travelled, I need to work out the area under the graph. So let's do this bit here. This is the constant speed / velocity. I'll put both words so we don't get confused. Okay, so to work out the area there, I've got a rectangle. So what I'm going to do is base times height. The base in this situation goes from 15 to 30. So therefore, I've got a difference of 15. The height goes from 0 to 16. So I'm going to do 15 times 16, which will give me, put that in your calculator, 240 meters. Okay, so let's do the deceleration section now. So the slowing down, that's the term that they've used in the exam, in the question. but I've labelled it as deceleration. So I'll put both. Now, this is a triangle. So we're not just going to do base times height. We're going to do base times height divided by 2. Some of you might do half times base times height. They get the same answer, so either way is fine. So here, the base is at 41. See how I've drawn that line so it shows us that it's at 41 and it goes to 50. So the base is 9. And the height, again, look carefully. You can do a line going across if you needed to with your ruler. The height would be 30. But I would divide that by 2 or times it by a half. They're both the same. And that would give me an answer of 135 metres. Okay, so I've got all my calculation here. So I've got the calculations to show the distance travelled when it's at a constant speed, and I've got the calculations to show the distance travelled when it's slowing down. But at this point, it says show the distance travelled. So I'm just going to write a sentence or a point just to prove that I know that this is a greater distance. Okay, so when travelling at a constant speed, the car covered 240 metres. When slowing down, it's only covered 135 metres. And there we go. That's all we need to write. Okay. See you again soon.